Question number 11. The line y is equals to 2x plus 5 intersects this circle at point A and B. Find the coordinates of A and B in third form and hence find the exact length of chord AB. All right, so let's sketch a circle. Okay, and from this expanded form of a circle equation, we should be able to state the center and the radius. Okay, since there's nothing adding or subtracting with the x and y, so the center is 0, 0, and the radius is going to be square root of 20 because this is actually radius squared. So the radius is square root of 20. All right, so we have a circle with center 0, 0 and radius square root of 20 and a line y is equals to 2x plus 5 intersects this circle at 2 points. And we have to find these points of intersection in third form, that is in square root form. You're not supposed to press ST in the end. So let's say this is A, this is B. We're going to now simultaneously solve this linear equation and this circular equation and use substitution method here and find the points of intersection. All right, so, okay, so the circle equation is x squared plus, I'm sorry about the mess, let me fix that. Okay, so x squared plus, in place of this y, I'm going to substitute and write 2x plus 5 whole squared is equals to 20. Solve this, x squared plus 4x squared plus 20x plus 25 equals 20. We get a quadratic equation 5x squared plus 20x minus 5. And we get, I'm dividing both sides with x, with 5, sorry, and I get this quadratic equation. Okay. Now the factorization is not going to work. We're going to use the quadratic formula. X is equals to minus b plus minus square root b square, which is 16, minus 4 times a times minus 1 upon 2a, which is just 2. So we have x equals minus 4 plus minus square root of 20 upon 2. Enter these individually in your calculators and I will give you the simplest most answer. For the positive one, it's going to give you minus 2 plus under root 3. And for the negative one, it's going to give you minus 2 minus under root 3. Okay. But the question asked us for the coordinates. That means we also need the y's of x and y, of a and b. So the y equation is 2x plus 5. You can actually substitute these values of x in either one of these equations, this one or this one. But of course, it's a lot easier to find y using the linear equation. That's what we're going to do. Y is equals to 2 times minus 2 plus square root of 3 plus 5. Simplify that, we get minus 4 after expansion and plus 5 would make that 1 and plus 2 square root of 3. And for the other one, it's going to be y is equals to 2 times negative 2 minus negative square root of 3 plus 5. And this would become y equals negative 4 plus 5 is again 1 and minus 2 square root of 3. So we have the coordinates of a and b. One of them would be negative 2 plus square root of 3 for the x. And for the y, it's going to be 1 plus 2 square root of 3. And for the other one, it's going to be negative 2 negative square root of 3 for x, and for the y, we got 1 minus 2 square root of 3. These are the exact answer. Do not press ST. Okay. So in the next part, they also ask you to find the exact length of the chord AB. So now we're going to apply distance formula on these coordinates. And let's do that. It's going to be square root y2 minus y1 whole square. So we have to be very careful. We have surds here. Y2 minus y1. Let's do that here separately. 1 plus 2 under root 3 y2 minus y1. Y minus 2 under root 3. Expand this. 1 plus 2 square root of 3 minus 1 plus 2 square root of 3. So we're getting 4 square root of 3 for y2 minus y1. Okay. And for x2 minus x1, let's do that here as well. So minus 2 plus square root of 3 minus 2 minus square root of 3. So this is going to be minus 2 plus square root of 3 plus 2 plus square root of 3. That also gives us 2 square root of 3. So plus 2 square root of 3 whole squared. Enter this in the calculator. 4 square root of 3 squared is coming out to be 48 plus 2 square root of 3 whole square is coming out to be 12. That gives us a square root of 60. So that is the length of this chord AB. Okay. Part B. Part B says that there's a point 10, 0. 10, 0 is going to be some point along this line because y is 0 on this line, and it's going to be outside of the circle. Let's say somewhere over here, 10, 0. Why is it outside of the circle? Because the radius of the circle was under root 20, remember? And under root 20 is actually just 4.47. So this point 10, 7 is way over 4.47. So it's definitely outside of the circle. Okay. So this is the point outside of the circle. And then it says that a straight line through 10, 0 with gradient m is tangent to the circle. So if you draw a tangent, you'll get a tangent like this. Also, you may get a tangent like this. So it says that with gradient m is tangent to the circle. Okay, so this line has a gradient of m. So y is equals to mx plus c would be the equation of both of these lines. And since 10 and 0 is given, we should also be able to find c in terms of m. 0 equals m times 10 plus c. That gives us c is equals to minus 10m. That means y equals mx plus c is minus 10m. This is the equation of the tangent. Okay. And it says a straight line through 10, 0 with gradient m is a tangent to the circle. Find two possible values of m. So of course, this will have its own n and this line will have its own m. And we go back to discriminant properties with this question. If a line is tangent to the curve, that means that b square minus 4ac is equals to 0. So now we need to get a b square minus 4ac. For that, we need a quadratic equation. So we're going to solve the circle equation and the linear line equation simultaneously. So I'm going to substitute x squared plus m x minus 10m whole square is equals to 20. Okay. If you can take the m common here, it's going to make the algebra a lot easier. Let me just show you how that's done. If it's, let me use bigger brackets. So one of the tangent is gone. Okay, so x squared, no, it's mx minus 10m, and then there's a square on it. If you take m common inside, you get x minus 10, and then a square on it. So you get m square x minus 10 whole square. So x square plus m square x minus 10 whole square equals 20. And now let's expand this. X square plus m square. This would be a square minus 2ab. So that's going to be minus 20x plus b square 100 equals 20. That gives us x squared plus m squared x squared minus 20 m squared x plus 100 m squared minus 20 is equals to 0. So we have x squared and take x squared common in both of these. 1 plus m squared x squared minus 20m squared x. That's the x term, and the constant is 100m squared minus 20 equals 0. Now we need to get the a, b, and c from these. Okay, so a is the coefficient of x squared. This would be a. B is the coefficient of x, that's going to be minus 20 m squared, and c is the constant, that's going to be this. So a is 1 plus m squared, b is minus 20 m squared, and c is all of this 100 m squared minus 20. So b squared minus 4ac equals 0 in the case of tangent. So minus 20m squared squared a square b square, sorry, minus 4ac equals to 0. Let's expand this. Okay, so we get 400 m power 4 minus 4. Let's multiply the 4 in the end. We get 100 m squared minus 20 plus minus 20 plus 100 m4 minus 20 m squared. Okay, so 400 m4 minus 400 m squared minus 80 minus 400 m4 and plus 80 m squared equals to 0. Thank God these two cancel out, and we have minus 400 m squared plus 80 m squared. That's minus 320 m squared minus 80 is equals to 0. But this should be plus 80. Yeah, this should have been plus 80. And this is also plus 80. Now we have m square is equals to 80 goes to the other side, becomes minus 80. Minus 320 divides with it. Minus minus gets cancelled. So you get 1 over 4 equals m square. That gives m square, m is equals to plus minus half. These are the two values of m. And that brings us to the end of the question.